Hello, and welcome to Chapter 5. In Chapter 5, we're going to be going over probability concepts. So in this chapter, we're going to talk about what is probability. Then we're going to talk about the types of random variables, discrete random variables, continuous random variables, and then more rules and property of probability. Before we begin, let's talk about a couple definitions. So a random variable is a numeric quantity that takes on different values depending on chance. Most of us have learned about probability and talk about it all the time. One big probability that you might talk about a lot is when it comes to betting and the Super Bowl coming up, the probability of something happening and the odds associated with it. Population is the set of all possible values for a random variable. Next, the event is an outcome or set of outcomes. Probability is the proportion of times an event is expected to occur in the population. Ideas about probability are founded on relative frequency, which are proportions in the population. So these are definitions that we're going to use. So probability illustrated. So in a given year, there were 42,636 traffic fatalities in a population of and equaling, we'll just say, 293 million. If I randomly select a person from this population, what is the probability they will experience a traffic fatality by the end of the year? Well, in order to do this, we take the relative frequency of the event of the population, so we take number of times the fatalities happened over the total population, and thus we get a proportion. And you can turn this into the probability of traffic fatalities is equal to 0.0001452. Or you can say 1 in about 6,887. Probability as a repetitive process. Experiment samples a population in which 20% of observations are positive. Figure 5.1 in the next slide shows two such experiments. The sample proportions approach true probability of the selection as n increases. So this slide here is very important to understand. It will be used kind of throughout the course. So in the long run, so this is in the long run, not in short term, the proportion approaches the true probability. So here's your trial 1 experiment. As you can see, is the lighter blue line, and trial 2, which is a little darker blue line. Now, with a small number of individual sampled at the very bottom here, so this would be 1 person to 5, 10, all the way up to 10,000. As you can see, if you have a small number, depending on which trial you are, you're going to have different chances, or the proportions of n of observations with the characteristics. So it's going to have different characteristics that you observe. However, over time, as you add more people to the trial, you see as they all kind of start really floating to that probability of 20%. What this is hopefully representing to you is that if you have a small sample size, you might not get accurate data. But as you increase the number of people in your sample, this is going to reflect a more accurate representation of the true probability that you're looking at. So as you increase n, you get towards the actual true probability of what you're looking for. Subjective probability. So probability can be used to quantify a level of belief. When we say probability, sometimes we use different verbiage. These are some of the verbiage. If a probability is 0% or 0.00, we would say it's never going to happen, right? The probability of me flying one day is never going to happen. I'm never going to be able to actually float. Now I can fly an airplane, but I'm never going to be actually float. The probability is 0. As our probability increases, it becomes, infrequent, not as often, very frequent, highly likely, always. If something always is going to happen, it's always going to be there. It's 100%. It's 100% probability. The probability class example. So here we're going to take a class example that uses males, females, the probability of selecting someone in the second row, probability of wearing a red shirt, and the probability of wearing a yellow shirt. So here's my little mock classroom. As you can see, here are our rows. So 1, 2, 3, 4 rows. Donated by, here's like a seat. And the F is for female and the M is for male. The color that they have is the color shirt they're wearing for that day. So this is just an example. So here's our entire sample set. And what we're looking at is, for the first one, males and females. But first we have to know how many people are we totally dealing with here. And if we add them all up, our N is going to equal 20 males and females. Broken down, males, there's 5 of them. Females, there's 15. So if we look at males up here, what is the probability of selecting a male randomly in the class? That'd be 5 over 20. Or you can write that as 1/4, or 25%. The probability of selecting a female is 15 over 20, or 3/4, or 75%. The probability of selecting someone in the second row. So this one we're just looking at the second row here. When we look at the second row, there's a total of 5 people in the row out of 20 people total in the class. So that's going to be 1/4, or 25%. So there's a 25% chance of selecting someone in the second row. What's the probability of someone wearing a red shirt? So this one we have to find how many people are wearing red shirts. You got 1, 2, 3, 4. 4 people wearing red shirts. 4 over 20, which is 20%. Or you could say 1/5 if you wanted to. The probability of selecting someone wearing a yellow shirt. So we look at our sample, we see one person's wearing a yellow shirt. So this one we're going to say 1 over 20, which is 5%. So there's a 5% chance of selecting someone wearing a yellow shirt for that day. Other examples you can use for probability that we use all the time, dice. If you have a 6-sided dice, there's a 1 in 6 chance of rolling a particular number on a side of dice. If you're looking at a deck of cards, there's 52 cards in the set, so if you wanted to pick a very specific card, like the Ace of Spades, you have a 1 in 52 chance of selecting the Ace of Spades. If you wanted to, say, pick the jacks, then there's 4 jacks in a deck, and you have 4 over 52, or a 1 in 13 chance of selecting a jack out of the deck. We use probability all the time. A lot of times, use marbles, in a bag and selecting a certain color marble. These are done all the time. You've probably done them yourself and have seen them. The next one is slides about random variables, but to really get into that, I don't want to break that up into different ones. I want to do that all in one video. I'm going to stop this video here, just going over the probability and the definitions of the probability. I'll see you all in the next video.